Testing microphone 4.
No, there were hot dogs. We walked past them and then like, there's hot dogs up there. Like, yeah, we're in Winnipeg. She goes, I'm so proud of you. Thanks. Thank you. I don't know who you are, but yeah. So if we ever want to join the class or the lab on Zoom, so like be in Zoom while you're teaching, do we have to let you know first? So
No, do whatever it makes you happy.
is the link available somewhere?
Yes.
The Zoom link?
Yes, I could. I believe I was sending, but I can resend it.
It's probably in one of the early emails that you sent.
Yes.
That's right. I don't know if it was just.
I think that as soon as we approach closer to the project, we will let it happen first. At the early stages, when we have slow ramping for first 2 months, it doesn't matter. Yeah. If you like, exponentially steeper and steeper.
You said COVID's probably going to increase. Is that what you're saying? You said COVID?
No.
Oh.
Intense steepness.
Oh,
like,
no.
More fear and kindness. Paper burn. Right now, maybe this number is too easy.
Success? A long way. Yeah. Did a bunch of bakes. We got out here before 8. I'll probably just go to the dining center. I can be mindful too. Right? Collectively. Yeah. We bring that. What's right today?
Smile, you are on the camera.
Not eating dinner until I finish this hospital.
That's the motivation, right?
Yeah, I think her motivation.
Starving yourself until you finish your
So
very healthy way of getting yourself to do your work.
yeah.
I have some stuff done. I don't know. Good enough. Guys, I think Snap out on my computer. Oh,
You got it?
it works. Yes.
Oh, congratulations.
I pressed one wrong button during the installation. And I said you have to reinstall it. Yeah. Works now. Like, is it possible? How am I supposed to open this without at least a little bit touching it? And I touch my screen all the time. Oh yeah, when I point at things or yeah. Like, which is funny that the camera's right there. Yeah, and then I put my fingerprints all over the camera. It's immediately. There are some computers where the camera's right here. That's like a low angle. That's really uncomfortable. You have to aim that up. I think it's a whole junction.
It is my
66.6 micrograms per ml.
Okay, I guess Sam might be joining us on Zoom.
Okay.
I didn't wake him up.
Maybe
so.
he's probably gonna sleep through it.
Does he know the link address? Huh?
But
He had a headache. He went
I don't
to.
know.
No, does he know the address, how to connect through Zoom?
Did you send it?
I'll better resend to everyone.
You know, if you really wanted to be here, you'd be here.
Yes, but I want to, how to say, keep the door open so that there will be no excuse like I didn't found the link, therefore I was not able to join.
So on topic.
Yeah, and we please. The Sam's gone, so that automatically.
Sorry, I believe I did send the link. Okay.
Wherever you are.
And in bed. Yeah.
Anyway, yeah, I don't think you.
Whew, thank you for investing your time and coming here. I'm really happy to see you. And as I see our like plans of progress through the class, we will have 4 presentations total, 3 midterms and 1 final project. And I think they will be kind of separated in time. So first 2 midterms will be a little earlier, and 3rd midterm and final will be later. And in between, it will be more than a month without presentations, where we pump our computational muscles and invest time in scary homeworks that will solidify our intention to do MATLAB projects rather than stuff. So coming Friday, in 2 days, you present postulates, and well, it would be too much stress if we do MATLAB presentations next Friday, but it will be quite soon. So we will cover all materials this time and next Wednesday, and then we'll discuss maybe on coming Monday how to schedule it. Maybe we can do presentations on MATLAB like not the coming Friday, but Monday after the weekend, something like that. And you'll see. Let's wait until you do presentations. You feel that it is much more pleasant than doing homeworks. And although some of you are nervous, you'll see that it is typically a positive experience. So what? Oh, okay. The subjects are there. So we did we symbolically split MATLAB skills on 3 parts. Last time we did cover everything up to vectors and Dirac's notation, and we'll go maybe everything until animation or everything until formatting figures. This is challenging if you never had linear algebra, and this is super easy if you had it. What else for the introduction? As we have seen in today's class, if you were caring about following what was happening on the blackboard, which is not guaranteed sometimes, the substantial part of the physical chemistry and quantum theory deals with finding, with solving eigenvalue problem. And eigenvalue problem is formulated in 2 ways. One as differential operators, as differential equation, eigenvalue problem, and another as eigenvalue for matrices. right? So if we get our hands on to getting eigenvalues and eigenvectors through matrices, we will have all necessary tools to go to applications. So it's practical tool to get through the course, and we will maybe have a little recital what are basic concepts of linear algebra, with intention that we will replace pen and paper solutions by as much MATLAB as possible. So it could be a little challenge, but all these challenges are intended to make our life as simple as possible later. So probably you're not taking 2 PChem courses in parallel for comparison, but if you would see that this strategy simplifies a lot of things. What else? Just, please ask some questions or with the discussion. And I will take, if you have some questions, I will take this couple of minutes to concentrate my mind. What do you remember from our last lab meeting?
Time independent.
This is not from the lab, it's from the lecture. Yes, yes. Uh-huh. Just the very beginning, right? It's a perfect cheat sheet.
Yeah.
Okay, yeah. Thank you for speaking for a little bit. It let me a breeze to concentrate mind. So this was important skills, but now we will, like, among the 3 lab sessions, it will be mostly complicated and concentrated intellectually, comparing to others. It's not like super complicated. Let me, and it should be enough time to get over it. Let's and finish by 7. I think it is okay. Let me make a little set of questions. How happy you are with linear algebra? Like, did you have it, or maybe elements of linear algebra in other classes?
Yeah, I took the short class.
Huh?
I took it in the summer, so it was 1 week.
So it was okay, but you were doing homeworks on multiplying matrices, something. Yes. Okay, that's good.
I took the
Full
full semester.
semester.
Yeah.
Okay, full, not fall. Oh, boss, full fall.
It was, mine was fall as well.
Okay.
A full fall.
Full fall semester. So I can rely on you as experts and you as supporters. Okay.
I might need to saddle up to you, Ava, and ask you questions. Well, we had our lectures were 2.5 hours long.
Okay.
Yeah, every day.
Oh, it means you forget everything next day.
Yeah.
Because it's too much.
No.
It's very intense.
You only had to know it for like a day. And then, yeah, then you're testing on it immediately. Sort of, that's about it. And then I learned how to do integrals.
As going through the life and career, I see benefits of calculus, differential equations, but when it was my time, I hated them so much. And it was also like full semester, and sleeping on lectures is okay. But then there were like practical sessions of like solving problems, both in class and for homework. And This is most hateful thing, and if anyone would offer me to replace them with MATLAB at this time, I would be so happy. Okay, so how do we organize the effort? I will try to make a little recital of really basic equations to make sure that we understand each other on definitions, and then we'll try to type them in MATLAB. Okay, and you all are invited to open MATLAB on your screens, and you do not need to do any notes. And I hope our recordings will go more successfully than last time. But if you really worry of your second midterm presentation, you may want, again, absolutely not mandatory, just giving a hint. You may do screenshots of if you do something that you're not confident, you want to have it recorded, like screenshot, put in a PowerPoint, and when it will be time for presentation, oh, I already have it. Look at it. Okay. Sure.
Logging into my Zoom for like 3 weeks. Well, no, you were gonna be logging into Zoom for like a week and a half. Because then we have an exam and then instructor's gonna teach our class for a while. Wow. Oh, no one sees my login. The password goes in and it's like gone. Yeah. I mean, I guess everyone in the class knows my name now. It sounds pretty. Yeah, our teacher was asking for someone to volunteer to log into Zoom on the instructor computer so that she could teach us over Zoom once she's done. And I'm listening to that, so I was like, I'll do it. And I had to practice. So I had to log into 3 different things. You have to log in. And then log into Zoom on the computer, and then she's like, "Oh wait, you can't start the meeting because you're a student. So you need to log in and access it through Blackboard. So you need to go log into Blackboard and then do it."
There should be an opportunity to include everyone into co-hosts so that you can start meeting, accept visitors. I'm trying to do it with every class, but there is a thing that I don't understand. Some of the attendees do have formal emails with NDSU and some with NDUS, and sometimes not both. And Zoom is kind of sensitive to it, so it will accept or reject for attendee to be a co-host based on. So maybe for the future situations like this, activate your both NDUS and NDSU accounts. I'm not an expert in this. I just noticed as a user. Okay, so what was our first thing? I already matrices, transponds, determinant matrix multiplication. Ooh, okay. So let's have our matrix A, like A, B, C, D, two by two, because it would be too much to do 3 by 3. And last time we were converting rows into columns, right? Which MATLAB symbol was used to do it? It is like if you do it's on the blackboard, and in MATLAB is apostrophe. Okay, so when we had like A, B with apostrophe will be A, B, right? And A, B, if they're real, if they are complex, it will be also complex conjugation. What are we going to get if we do this little apostrophe to a matrix? So whatever. Mm-hmm. So it is just swaps the off-diagonal elements, right? And if they were complex, it also makes them complex conjugate. So let's just try it right away. Maybe a.
2 rows and 2 columns.
I like your questions. So 1, 2, then enter. 3, 4, and then close the bracket. Does it answer your question? Okay, so if I do, so what should I get if I type A prime? Should we swap 2 and 3? If I type A prime? Yes, it is. Okay, and if I do like B equals I 2I, maybe here I'll do real, and then I do B prime, then those that had imaginary parts swapped their factors in front of I, and those that were real didn't change. Okay, so what's done with transpose. Next, determinant. Oh, why did let's see number 2. Why and how humankind designed matrices? Like
I don't know if I have an answer to that question.
I'm somewhere somewhere.
yes.
Values of equations.
Mm-hmm. And which equations? Like, no. Suppose I have 2x equals 3, which means 2 people wants to share 3 apples. 2x equals 3, and the answer is how many apples each person will get. You divide both by 2, and x equals 3 seconds, so 1.5, right? Do we need matrix for this equation? No. So which sort of equations do need matrices? What would be the exactly? So as soon as we need to right, so when we have multiple variables, and if we do have equation, if you do have like 2x equals 3 is too simple, but if you have 2x plus 3y, okay, and then 4x plus 5y equals 6, right? So this equation may benefit from using matrices, right? So how do we write this equation in a matrix form?
Big line.
2, 3, 4, 5 times x, y equals 4, 6. How do we solve it?
Now you have to take the inverse.
It's music to my heart. You do not need this course. You already passed. So one way is to balance, like add and subtract, and then get x and y. But if it is like 100 dimensions, it would need something more advanced. Yeah, if this is matrix A, this is unknown vector x, and this is like known vector c. So I'm just translating the words of Elsa. You told it, right? So if we assume that there is such matrix A minus 1, which would convert this into unitary operator, just diagonal matrix, and we apply it here, A minus 1 times C, then it will be x equals A minus 1 C. And then we have a solution, no matter what is the amount of dimensions. Good. So what is an inverse matrix? Something that makes it multiplying by the matrix, it generates 1, 1, 1, 1, 1, and zeros everywhere else, right? Is there any prescription how to generate this inverse matrix? Of course, we can solve this equation for each matrix and do it over and over again, but probably people were doing it for centuries, and there is a little algorithm. Huh? Determinant will be a factor in this. So if we do have our A matrix is A, B, C, D, right? Then A minus 1 will be an algebraic complement. Are you happy with this terminology? Algebraic complement? Me too. So if we select element A, then we cross out everything here, then the remaining part here will be algebraic complement. Or if it will be not an element, but submatrix, it will be determinant of this thing. So I think it will be like D, algebraic complement of A, then A will be algebraic complement of D, then it will be like C, B, and this thing needs to be divided by determinant of A. The whole thing or this DETA?
Switch the sides.
We do. Thank you. Thank you, Mavri. No, it's great. Okay, so for higher dimensionality of matrices, it will be a little more complicated, but now we need the determinant. And even if we do not have everything clear, we have a strict logic. If you have multidimensional algebraic equations, we may utilize matrices to solve them quicker. Now, the determinant is needed in order to find inverted matrices. What is determinant? And why do we need it? Yes, but it is only a symbol, but it doesn't show the definition. And determinant means it determines something. So it determines if our original matrix is good or bad in respect to some property.
ones and subtract the other cross.
Yeah, it's AB minus BC.
Mm-hmm. You all agree?
Yeah, the only.
Of course, you agree with yourself.
If it's more,
If it's bigger than that, like different coverage, then you can look it up.
But then one splits on submatrices and right. So determinant of A, B, C, D will be AD minus BC, right?
Yes.
Okay, let's give an example. If it is like 2, 3, 4, 5, determinant will be 2 times 5, 10, minus 4 times 3, 12, so we minus 2. Okay, let's make this little experiment. Let's redefine A as 2, 3, 4, 5. And now let's try just to type DETA minus 2. So MATLAB is at least as smart as we are. Okay, so it did prove to work for 2 by 2, and now we can, bless you, bless you, bless you. We may start believing MATLAB in bigger matrices. Okay, so determinant is done. Now, well, let's do inverse matrix and then do matrix multiplication. So if we do have matrix, it's too complicated. Let's redefine it with something simpler. So let's, we do have two matrices, A and B. Let's recall the rule of multiplication, get it on a board, and then check if MATLAB will give the same thing. So do you have your permission to erase? Okay. So how do we multiply them? Wait, let's, this is correct, but let's organize our effort. So multiplication of two square matrices will be another square matrix. And then we, of the same dimensionality. So we will need to populate the, if it is 2 by 2, 4 elements, right? And if you need to populate element number 1, what is the, how do we call the rule? Okay, so row by column, right? And then we do 1 times 4 plus 2 times 2, which will be 8. Okay, and then we just continue. If we need a second element, we select the row where this element is placed and the column where the element is placed, right? I'm not lying? Okay, so 1 times 3 plus 2 times 1, 5. And here again, row times column, 3 times 4 plus 4 times 2, right? 12 plus 8, 20. And here, again, row times column. 3 times 3 plus 4 times 1. 9 plus 4, 13. Okay, so if we understand it correctly, we should get 8, 5, 20, 13. Now let's see. 8 times B. 8, 4, 20, 13. So we can trust MATLAB in this as well. Would result change if you swap the order? Huh?
You have the same numbers, but they're in different spots.
So it's like transverse. No, it's no, but at least it differs. By now we are fine with it. Okay, so we did matrix multiplication, and now we need inverse matrix, right? Which we already defined, but let's practice it once again. So if we define a minus 1 as the determinant will be 1 times 4 minus 2 times 3, 4 minus 6 minus 2, right? And here we do for 1 minus 3 minus 2. Please correct me if I'm wrong. I like making mistakes.
But 2 and 3 don't switch places,
2 and 3 do not switch places?
right? The 1 and 4 switch, the 2 and 3 don't switch places, but their signs do switch.
Okay,
So like
let's.
4, -2,
So
-3, 1.
okay, and then everything must be divided by minus 2, right?
Yes.
So will be minus 2. Minus 2 divided by minus 2 will be 1. 3 divided minus 2 will be minus 1.5. 1 divided minus 2 will be minus 0.5.
So 1.5 is positive. Is this -3?
Negative? Yeah, thank you. Now, before checking if it is correct with, if it agrees with MATLAB, let's try to double check that it is an inverse matrix just by multiplying these two. -2, 1, 3 halves minus 1/2. 1, 2, 3, 4. So again, it should be 4 elements. So minus 2 times 1 plus 1 times 3 will be 1, right? Next, row by column. Minus 2 times 2 plus 1 times what? 4? So minus 4 plus 4 will be 0, right? At least first row matches the expectations. Now let's do the rest. So 3 row by column, 3 halves times 1. 1. And then minus 1/2 times 3. 3 halves minus 3 halves will be 0. right? And then row by column, 3/2 times 2, row by column, minus 1/2 times 4 will be 6 minus 4 divided by 2 will be 1, right? So we are obtaining the matrix that serves, that is diagonal and has ones on the main diagonal and zeros everywhere else. So if I would practice this alone, I would do at least 5 mistakes and would fail, but with your help, we got it. So the, let's call it INV of A, inverse. Let's check what we got. So minus 2, 1, 1.5, minus 0.5. It looks like an inverse matrix, right? And then we do this AA times A, we get the diagonal matrix, the unity operator. Are we convinced? Here, AA is inverse of A. Okay, let me walk through the sheets and make sure that everyone is happy. Okay. Okay, and you can. Oh. Do not rush, do not rush. Okay, good. Okay, so we are done with the first row, transpose determinant multiplication inverse matrix. And now we get into most complicated thing, eigenvalue problem. So who remembers how to find eigenvalues?
I wish.
But the question of finding eigenvalues doesn't surprise you. Eigenvalues. Who knows absolutely nothing and is surprised even by formulation of a problem? Who knows everything and is very comfortable, and who have heard something but not.
No, it was the last thing we learned. Yeah, we like kind of crammed it in at the end of the semester.
Okay. So the multiplication of matrix A onto unknown vector, column vector X, should give the eigenvalue A and vector X. So the idea of this eigenvalue problem that if it is two-dimensional space, all vectors are just pointing on a plane if we skip complex. If we allow complex two-dimensional vector, we'll be in four-dimensional space, but it's okay. In the all possible orientations of these two-dimensional vectors, we need to find such vectors that I just fail in grammar and language, no matter in which language. I just do not know how to, I'll try to say it in the wrong way and then I'll improve my linguistics. Such vectors, by acting on which by that matrix, we get the same vector again. Make sense? Or more simple, applying a matrix to a vector doesn't change a vector. So this vector is near and dear to this matrix. So matrix doesn't change the vector, right? Okay. And some smart geometrical mathematicians even know how to make geometrical analogy of the statement, but it's too much for me. We'll just go with simple algebra. So this vector x can be represented as maybe like x and y, or x, like two elements. And if our right now we have some specific numbers, but more generally, it's like either A, B, C, D, or one just puts indices, right? Now we need to put this A, B, C, D acting on vector which is x and y. Let's put different letter lambda. We'll give this eigenvalue and then the same x and y. Again, I was not showing this important writing. Those who are on the recordings, please enjoy this magnificent calligraphy. You can do better. You can do better.
I think I'm excellent at drawing lambdas.
So I know that only two of you have a little bit declared that you have some memories, and other two declared that you never saw it. But can you remind me, what if we have this task and I have forgotten completely? What should I do? How do I find which lambda I need to find x, y, and lambda? What do I do?
Matrix and remote. Assuming it's trying to how to do it.
Good.
Top left, bottom right, those values and subtract lambda or lambda.
Mm-hmm. Perfect. I love it. They both will work. There will be more than one solution. Does it make sense? It's absolutely perfect explanation. I cannot do better. Do you guys follow? I cannot repeat better. Okay, I'll try just to follow Eva's instructions. Okay, so before going forward, let me do some tricks. So math allows a lot. Math allows a lot of liberty. It sounds a little strange, but okay, maybe it's restricted liberties, but the equations, parts of left and right part, can be multiplied and divided by the same number without breaking the identity, the equality. Or both left and right part can be added and subtracted the same number, right? And at the same time, any vector can be in the identity can be multiplied by unity matrix, right? And then the result will not change, right? It's our mathematical liberties. We can do it, we can apply it right here. And I suggest we put an unity identity matrix right here. 1, 1, 0, 0. So I'm practicing my liberties. Okay. Now, can I subtract one from another? Can I? Why? Why? Look here. This lambda multiplied by matrix can be moved here, like lambda, lambda, right?
And then it's lambda minus 1
Hmm?
for both of them, right? That sounds familiar.
We will have a minus lambda and d minus lambda, what you told to us. But now I am going to subtract this right-hand side from left and from right. When I subtract it from right, it will be matrix populated with zeros. When I subtract it from left, it will be something interesting. So on the left, I'll have A, B, C, D on xy minus lambda, lambda, 0, 0, x, y, and should be equal 0, 0, 0, 0. Right? Now, here I can put x, y vector away from brackets. So I can put brackets, and remove it here. Okay? And now I can subtract two matrices, which means we subtract element by element. It will be A minus lambda, B minus 0, C minus 0, D minus lambda times vector x, y equals 0.
Then you can make like a series of systems or like a system equation?
Yes. And in order to find, so here there are the number of rows in the matrix tells how many solutions are expected. There are two rows, there will be two solutions for lambda. And we can temporarily completely get rid of this x and y vector for the period of time. And I'm not going to prove, it's just following the prescription. If you take determinant of this matrix and make it equal to 0, then it will convert, as Eva taught us, into polynomial, which we know how to solve, right? I'm going to, you enjoyed this calligraphy enough, right? I'm going to erase everything except the. Come on, this is in every textbook. Okay, I'm deeply touched that I make a competition to all textbooks of linear algebra. Okay. So we do determinant of this A minus lambda, B, C, D minus lambda. And determinant is diagonal times product of diagonal minus product of off diagonal, right? So A minus lambda, D minus lambda, minus CB or BC. And we need to make it equal to 0 in order to find values of lambda. So if I decide to open the brackets, it looks like an exercise in like last year of middle school, right? So A D minus lambda D minus A lambda plus lambda squared minus CB equals 0. No errors yet? Okay. And now we can just reorder all terms with lambda first power, all terms with lambda second power, and free term. So lambda squared minus A plus D times lambda plus AD minus CB equals 0. Huh?
Is that lambda to the power of b? Lambda squared.
I'm just opening brackets here, right? Okay, so please share your experience. How do you solve such equations if A, B, C, D are known and lambda is unknown? Do you have any memories from your last year of middle school? Yes. Okay. Everyone agrees? Okay. Oh, the only guy in today's audience left the room. And the question is less for girls, more for guys. But when you're surprised, all guys around. So which problem in human's life induced necessity to solve these quadratic equations? So,
Oh no.
Probably wouldn't understand.
so yeah, man's question. So, which practical problem of human's life induced necessity to solve quadratic equations? It's not a joke. It's no. It's maybe boring and serious and simple, but there is a reason.
I don't know.
So
Like the shape of the graph. Well, I guess I mean if you don't know what graphing is, that wouldn't help.
like what did you get in your middle high school physics? How did it start? Yes. You have A in physics. I will sign it even. a little bit more. So why humans need free fall? Like Galileo was climbing to the tower. Sure, but baseball is for entertainment. But it's we all
Have to do with terminal velocity.
see ballistic missiles, right? We all are peaceful scientists. We are for the peace everywhere, but historically it happens all the time. So when like ancient Romans and Greek were trying to like throwing catapults, right? And one needs to predict where the projectile will land, right? Or later on, at the time of Galileo, people started to load like cannons with this spherical thing, and then it goes for X projection, it just goes linearly, and for Y projection, it goes against gravitation halfway, and then halfway to gravitation, and one can compute the time when it will land, plug this time into X projection, and predict where your projectile will land. So it's a basics of artillery shelling, and it is a well. Unfortunately, although we are all for the peace, this was a problem that induced this effort to solve quadratic equation, and they moved math forward. Okay, how do we solve quadratic equations? Like if here we have some big A, I will reuse it. Big A, here we have big B, here we have big C. Then lambda is So plus minus square root b capital squared minus 4ac
All over. Wait, you're missing out front.
b
Yeah, negative.
negative.
Oh, negative b plus minus square root of b squared minus 4ac all over squared.
Okay.
I didn't even know that.
That's the quadratic formula.
So our a capital is 1. If our a is 1, d is 4, so b will be minus 5, right? And then a is 1, d is 4, c is 3, b is 2. So 4 minus 6 will be minus 2. So if you plug it into here, will be plus 5 plus minus 25 minus 4 times 1, 2, right?
Yeah. Minus 4 times 1 times negative 2.
Okay, so 25 plus 8 to complete, right? 33. Okay, square root of 33. So will be 5 plus minus square root of 33. If I would be a good teacher, I would select such number that would give some easy to take square root, like to have here 36 or 9. Okay, 5 plus minus square root of 33 divided by 2, which will be 2.5 plus minus square root of 33. 5 plus minus square root of 33. Square root of 33 should be something close to 6, right? Because 36, yeah. So yeah, over 2, correct. Yes. So 5 plus minus 3 approximately, right? So will be about 0.5 and about minus 5.5. Let's check if I did any mistakes. If MATLAB will bring us close to this. So, and UV equals eigen, because eigenvalue problem of A. So U will be solutions for eigenvectors and V will be solutions for eigenvalues on the diagonal. So one solution, I think I screwed the sign, but with absolute value, it is quite close. So one is close to 0.5 and another is close to 5.5, but the signs are opposite. So I think it was my mistake rather than MATLAB. But whoever will be presenting it may select a better example to compare human way and MATLAB way. And the only thing that we need to memorize is this little, how to call? Yes. So it's a little strange. Typically we write like y equals function of x, and here we have two functions depend on this outcome of this subroutine, because we do need both eigenvalues and eigenvectors. So here are eigenvalues, and here are two columns of eigenvectors. And if one plugs them into the equation, one will get the right answer. So maybe we can first try some homeworks with pen and paper, and then try some homeworks with MATLAB assistance, but this command later on will be used again and again in the projects. So we need to be comfortable with running it. So let me walk along the seats and make sure that you are enjoying MATLAB commands. Mm-hmm. Mm-hmm. Okay.
So what is this one?
Eigenvectors. So those are x and y for first lambda and for second lambda.
Oh,
Okay. And if you insist, I will keep showing and deriving, but maybe we can skip it. Okay. So where we are now? Eigenvalue, analyze eigenvectors. I do not want to show it. Maybe we'll return to it next time, or okay. It's important thing, but it's very exhausting.
Yeah.
Yes, let's assign this to Sam. Okay, visualize a matrix. Okay, the rest is easy for today and for next meeting. So last time we were plotting the functions, and for the matrix we can do bar 3a.
yes.
You can, okay.
Is bar 3 just the name of that chart within the program?
Yeah, it is a subroutine to visualize matrix. You see, here is a 1, 2, 3, 4. Like 1, 2, 3, 4, right? So it's just make a little histogram. And one can apply it as well to like our eigen values and eigenvectors. And definitely it will work for any dimensionality. Like as soon as we get bigger than 2 by 2 or 3 by 3, there is no way to treat it by hand. Okay. Visualize a matrix. It may be not enough for a single presentation. It should be bundled with some other questions. 2D plots of 1D functions versus 3D plots of 2D functions, surfaces. Okay. So if we disappeared, did I stop Zoom meeting by wrong button? Still recording? Work?
Look in the upper left corner.
Upper left, yes. Okay. Yes. Good. So last time we were doing like x changing from whatever 0 to like 10, and then plotting a function like x comma x squared, right? What's the question? From 0.
Right. No, the
Period? Oh, if I do not do it, it will garbage the whole screen with numerical values of this.
Oh, that's right. It's so it doesn't.
And if you go from 0 to 10 by step of 0.1, it will be like 1,000 numbers,
Yeah.
which I do not, and they're kind of very predictable. I do not want to watch them. Okay, and one can set up another variable like y, and then there are several ways of three-dimensional figures. So one can do what 3x. Let's do cosine x, comma sine y. So what do we see? In some sense, it is an illustration of today's lecture, like a plane wave, because for the e to the power I px, it is real and imaginary part, right? Real behaves like cosine, imaginary behaves like sine, and if one tries to imagine the plane wave, then here the x-axis is argument, is the phase or action that is accumulated along the path, and the y and z will be real and imaginary projections of the plane wave. So this, we can do it a little quicker, accumulating a spiral that has more coils. So this would be like a parametric plot. Sam, hello, nice seeing you connected. Okay, and right now we do have good to be here symbol of smile. Yeah, yeah. Thank you for the sharing the positive emotion. So this was a parametric plot, and there we have one argument and two functions, right? And one can do opposite when there are two arguments and one function. For example, if you do mesh x, y, and then x squared plus y squared. It doesn't like me. Okay, better. Okay. Well, it's not very spectacular, but okay. And let's play with it a little bit more. So it wants correct dimensionality. So maybe if I do once of y, no. Oh, okay. Once size y. Okay. Now plus. I will beat it. So here we'll keep y, And here we'll do once size. Okay, it's just almost the same thing. And now we can do it while I'm playing with it. You can guess, or you can experiment. So what is your guess of the once command? Okay. Now I don't need anyone. I just having fun myself. Let's go from -10 to 10, and same for the x. And now this little command. Okay, it is what I wanted to, like a little, how to say, cup or surface with a minimum. So here is an illustration of when we have two arguments, x and y, and one function. So it will be like x squared plus y squared, like two-dimensional parabola. Question of melody, what is once? Let me, no. Colors are just ramping from minimum to maximum according to rainbow. But let me do like another variable, like g will be from 0 to, let's say, 5 is step 1. And now if I do size z, what I'm going to get? So it shows that it is a matrix 1 by 6. If I use our matrices that we used before, it will show matrix 2 by 2, right? If you do size z prime, it will show matrix 6 by 1, so rows to the column. Now, if I do this once, then it creates an object of the same dimensionality, but populates it with ones. Okay, and if I do not like ones, I can type zeros. Okay. So we are done with visualize a matrix. 2D plots of 1D functions, 3D plot of 2D function surfaces. Basically done. Let me do, oh, there is one more comment. Right? No, it's same good to be here comment. A lot of practical effort to projects, which I believe you will select over comparing to solving problems, we'll be dealing with solving real life problems with MATLAB codes, but then visualizing solutions in forms of functions and surfaces. And in addition to this mesh command, there are few more. For example, if I do have an ancient computer that takes too much resources to do this color map and two-dimensional image, I can type contour, and it represents a function by like geodesical lines as on the map, right? And there are a few more commands which I can type help mesh, and it will explain what this command is, and at the end, it tells what are alternatives. So mesh C, mesh Z, waterfall. Let's try waterfall. It takes a little time to process. Maybe waterfall is more computationally expensive than mesh. Yeah, it's still thinking. So maybe it's not a good idea to. What are like here we have a matrix of 1,000 by 1,000, which is a little challenging for waterfall. One would prefer something like 100 by 100, and then it will go a little quicker. But whoever will be presenting the subject may do this experiment, or we can practice patience and see what happens. So basically, it will do mesh maps everything, and waterfall does lines along X that repeats the same surface. So it's like representing as an object with snapshots. And if we have very fine grid points, it still looks like a surface. So it is more appropriate if one wants to have less data points, but still get an idea of multidimensional surface. Okay. Format figures, background, font, line, thickness, color. So X label X. You see little X pops up here, right? And one can, if you want to have a competitive figure for whatever publication, one may want to increase the not line width, the font size. You see, it's a little bigger, right? And Z label X squared plus Y squared. So it just writes down things. In each version of the MATLAB, mouse-operated commands are changed. So I will try to do something, but I do not like promise and guarantee. But if one selects this little arrow and double clicks, it is expected to. Maybe I need to redo mesh, otherwise it is too time demanding. I think part of the resources of the computer goes to the streaming Zoom, and therefore it is a little delayed to compare to what is typically expected. So it tells busy at this corner. So if I lose patience, I may just quit MATLAB and rerun it. Or start it from the cluster. Let me walk along the seats and check if you feel comfortable in doing something interesting, and then I'll probably terminate and restart it here. Sam, please try to do similar exercises on your MATLAB, and after making tour over in-person presenters, I will ask you to share screen and watch what you are doing. I hope to find there exciting computer games. And I will make you co-host. No? Oh, on this computer, I'm not a host. I need to do it on another one. Make co-host. Yes. Yes, please do some. So and until Sam learned that he will be sharing screen, he didn't run MATLAB, I think. Can you show the image? Okay. And if you double select the arrow, then point on the screen and double click and see what happens.
I've only been sort of following. I apologize.
That's okay. That's okay. Nothing interesting happens. Okay, I'll probably show there and then see what happens.
Figuring it out.
Okay.
I got that.
What are you doing?
You got any images?
No, not yet. I was mostly listening. But I'm copying the waterfall, or I guess maybe mesh would be better.
Yeah, mesh is a little more conservative. Agreed. So here's a Sam number 2. Making him a co-host again. Yes. Okay, Sam, you can share your screen.
Hi, Sam.
And also you can share your microphone, your camera, and your screen all together. We do not hear him. Maybe he is speaking and we do not hear him. I think we need to do another experiment and select several. You said something? I have to join my other computer. No, it was before. We need to make an experiment on trying several speakers. Testing speaker number 1. Testing speaker number 2. Simply try saying to the speaker number 2. Testing speaker number 3. You're here again. Test things. Oh, I don't need Sam for this experiment. I can speaker, but we do not hear it from there. So speaker number 4 is not good.
Nope.
Yes, Sam, I hear you from the laptop, but it creates a strange feedback.
Oh, okay. I wasn't getting any feedback on my side, so actually that's good.
Oh,
hello.
Better. So finally, speaker number 4 works. So we need microphone number 4 and speaker number 4. Okay. So Sam, please share your screen.
Sure.
Show us something.
I'll just show MATLAB. Here you go. Kind of don't really know exactly what's going on because I joined in so late. You kept doing mesh and the XYZ and stuff. I don't exactly know. Did you end up defining like an X, a Y, and all of that, or I was kind of confused on that.
I have an idea what to do. I will just share a couple of commands and you just try to repeat them. So copying and sending them over into the, just try doing this command and see what happens. Do you see something in Zoom chat line? Yes.
Yes. Do them separately?
No. Now there should be a popping up window with image, and you need to bring it up.
Okay. I do indeed see it. Let me change what I'm sharing.
It's better to share your whole display rather than a single screen.
Oh,
yes, it is here. Okay, yeah, you're good.
Perfect.
Okay, you can stop sharing.
What if I don't want to?
Okay. Yeah, I think my MATLAB here is frozen. I need to quickly stop it. Quit. Run. Okay. I don't want this. So what? So if one double clicks on the graph, and for exercises, it's better to do one-dimensional. They are a little simpler, and later on one can do it with multidimensional. There is a popping up window that allows to modify how things look like line width, maybe thicker line. And if one double clicks on the ticks axis with grid point, one can increase the font right away. So there should be also an opportunity to change the background color, the thickness of the box, and these little exercises are needed when you present your figures for to show it to outer world. If someone is really skilled with MATLAB, it can outperform Microsoft Excel or Origin and other drawing tools. It's a little less user-friendly, but it has all these functionalities, and one can, yes?
Sorry, continue explaining. I have a question for when you're done explaining.
I think I'm done. Go ahead with your question.
Okay. Labels my X and Y axis, but they're not showing up on my figure.
Do you have one figure or more? Are you sure? Okay, you have one figure. Okay. Sometimes the labels can be a little away from the axis, and when one is going to convert by printing, let's do this little experiment. So X label test. So
that's not good.
okay, so your question is resolved, right? So I'm sharing something on the big screen that probably doesn't get broadcasted to SEM, but line thickness. So format figures, background. Right now, I don't remember how to do it. So whoever presents will find it out. Font, yes. Line thickness and color. Yeah, line color, it is something we should do. We partially did it last time, but let's do it once again. So one can select a color just by like letter R stands for red, right? If you do G, it stands for green. If you use B, it will be blue. And one can also do blue dashes or blue dots or blue dashes and dots. This is needed in case you have more than one figure per plot. Also, you see you probably already start hating either MATLAB or Instructor or the display because it is too small, right? So if one does line width parameter, one can make it a little bigger and thicker. There is a way to if one reads the manual and help, it will give symbols, but let's do things not by command, but by this mouse operated thing. So you see color 001. Elsa, is it enough purple for you? And those things are needed when is doing several lines, right? Several like data points, fitting curve, alternative, and comparing them. Yes.
Wait, so you the design and the color at the same time?
Yes.
Is that something you have to do manually, or is there a code for it?
There are ways to type it to control all these parameters in the command line. But from the top of the head, I know only the basics. If one does advanced, one needs either to play these mouse operated commands or read manual for more command line options. Sam, would you like to share your screen and show your success in multiple lines?
Unfortunately, there is no success as of right now.
Okay.
I'm currently trying to figure out where I went wrong. Did that.
Okay. Well, let me.
Why is that such?
So I will make a little tour to see your.
I was gonna say, I think I did it right. I'm just trying to change the width, and I don't know. I don't know what's going on.
Okay. I don't know how about success, but I feel that you all are having fun of drawing. Huh? Okay, it was my purpose. Physical chemistry should be fun. Should be fun. Okay.
Oh,
I think movies should be postponed to the next meeting. Yes. Yeah, but if you have questions, feel free to stay and ask. But if you are tired or if you feel it's time is up, feel free to leave. So we are done. Where's the camera? We are done for today. So the next time, well, on Friday you do presentations. I'll resend you the announcement if I was successful in rescheduling our meeting into this room with a reservation. If not, I will just bring a little camera like this. But stay tuned and please send presentations in whatever 30 hours. So why we are postponing animations to the next meeting? If you saw this little program of the basic skills, next Wednesday we all will become certified programmers. So MATLAB is not only a scientific calculator and matrix laboratory, it also gives ways for scientific programming, for writing little codes, and it is very easy. But making movies needs a little programming. So it's maybe like 3-4 lines code that I'll share. And if you start it now, it's possible, but it will be a little too much. It is fun. It is not complicated, but it would take more than 15 minutes that we have until 7. And we try to split effort evenly. Okay, meeting is done. Everyone is welcome to disconnect and leave. If there are questions in class or online, feel free to ask. If no questions, feel free to disconnect.
all right. Bye.
Why? Yeah, see you. Good night.